Welcome to the Center of Math's Advanced Knowledge Problem of the Week. For this week's problem, we're given subsets Q and P over a topological space X. We're given that Q is connected, P is open and closed, and that the intersection between Q and P is not 0. It's not the empty set. We want to prove that Q needs to be contained in P. So to prove this, essentially, this is based on the fact that P is open and closed, and thus the complement of P is open and closed, and so we can, so we can proceed by contradiction. If Q is not, we can assume Q is not contained in P. So there is some Q outside of P, and so we assume Q is not contained in P. We know P is open and closed, but the complement, since P is closed, the complement of a closed set is open, so P complement is open. The complement of P and X. And so the complement of P and X and P, the union of these is just all of X. And we know Q is a subset of X, so Q is contained in X. So Q is contained in the union of P and the complement of P and X. But these are two disjoint open sets, and so Q is a union of two disjoint open sets in X, and this contradicts that Q is connected. And so we conclude that our initial hypothesis that Q is not contained in P is faulty, and Q must be contained in P. And if Q is contained in P, then the complement of P does not necessarily, the intersection of the complement of P and Q has to be 0 if all of Q is contained in P. And that solves it, so we conclude Q must be contained in P. Thanks for watching. Please check out centermath.org, check out our blog, and follow us on Facebook and Twitter. Thank you.